All right, welcome back to the deep dive. Today we're going to be focusing on something that might seem kind of basic at first, but it's absolutely crucial for how helicopters fly safely and effectively: weight and balance. And for anyone out there wanting to quickly get a real feel for why these seemingly simple ideas are so incredibly important in the world of rotorcraft, well, you're in the right place.
Absolutely. We're diving deep into the weight and balance chapter from this HFT HAO6.pdf document. We really want to break down the most important principles here for you.
Yeah. Consider this like a shortcut to figuring out what really matters. No need to get bogged down in the weeds with this one.
Exactly.
It's all about understanding the core of helicopter weight and balance limits and really grasping what they mean every time you take one of these machines up into the air. So let's just kick things off with a fundamental question. Like, why is all this weighing and balancing stuff so critical in the first place?
Well, to put it simply, sticking to those weight and balance limits is the absolute cornerstone of safe helicopter flight.
Yeah.
It's not just a suggestion. It's not just a good idea. It directly impacts the strength of the helicopter itself. Push past those limits, and you're putting the helicopter at risk of serious damage.
And it's not just about the total weight, is it?
No, not at all.
What really kind of struck me in this document was how even a tiny shift in the center of gravity, we're talking sometimes as little as 3 inches on a fully loaded helicopter, can totally change how the helicopter handles. That's a level of sensitivity I hadn't fully appreciated before.
That's true. It's a fascinating concept,
Yeah.
Like, imagine you're trying to carry a tray that's perfectly balanced.
Right.
Just the slightest little movement of something on that tray can make it much harder to control. A helicopter reacts similarly to shifts in weight distribution. It's just a much more complex system. Operating outside those carefully calculated weight and boundaries is absolutely unsafe. The FAA H-83-1 handbook goes into even more detail, but we're distilling the key takeaways right here for you.
Perfect. So let's dive into what actually makes up the weight of a helicopter. Obviously, it's not just the helicopter itself, right? We got to think about everything that's going into it, especially if we imagine we're loading up a helicopter for like a rescue mission.
Exactly.
So beyond the fuel and the crew, what are all the things we got to factor in when we're calculating the weight?
Well, we start with the basic helicopter itself, as it comes from the factory. Then we add the crew, any passengers, all the cargo or equipment for the mission, and of course the fuel. It's important to keep in mind that while the effective weight or the forces acting on the helicopter during maneuvers changes in flight, our initial focus is on the total weight of the helicopter sitting on the ground, ready for takeoff.
Gotcha. But the document made it clear that the maximum allowable weight isn't just a fixed number throughout the flight, right? It can change depending on what's going on.
Absolutely. This is especially true when you're thinking about out-of-ground effect hovers or operations in tight areas. Like, you might have enough lift early in the morning when it's cooler, but as the day heats up and that density altitude increases, which happens with high altitude, high temperature, and high humidity, that maximum allowable weight might have to be reduced to make sure the helicopter can still perform safely.
Density altitude, that tricky factor that seems to complicate so many aspects of aviation. So it's like if I'm flying on a hot day in Denver, even if my weight is okay according to the manual, that thinner air at altitude is like the helicopter is trying to lift a heavier load than it would at sea level.
Exactly, you got it.
Yeah.
It's almost like the helicopter has to work harder in that less dense air, so to maintain the same level of safety, you might have to reduce the overall weight.
Okay, so we've got the basic idea of total weight and how it can change. The chapter brings up some specific terms. Let's unpack a few of those, starting with basic empty weight. What's included in that?
So basic empty weight is essentially the helicopter's starting weight.
Yeah.
It includes the standard helicopter fresh off the assembly line and the optional equipment that's permanently installed, unusable fuel, and all the essential operating fluids, things like engine oil, transmission oil, and hydraulic fluid if the helicopter uses a hydraulic system.
Gotcha. And then there's this other term, licensed empty weight. What's the difference there?
Licensed empty weight is similar to basic empty weight, but the big difference is usually how the oil is accounted for. It usually only includes the undrainable oil. So if your aircraft documentation lists a licensed empty weight, you got to remember to add the weight of the full engine and transmission oil to get a complete picture of your helicopter's weight before you start loading it up.
Right, so basic empty weight usually includes all the fluids, while licensed empty weight might need you to factor in the full oil tank separately.
Gotcha. Yeah.
And then there's maximum gross weight, which sounds pretty self-explanatory. It's the absolute heaviest the helicopter can be. But the chapter mentioned a few nuances there that are important to understand.
You're right. On the surface, it's simple. It's the maximum weight the helicopter is allowed to be.
Right.
However, most helicopters actually have two maximum gross weights, one for internal loads and one for external loads. The internal maximum gross weight is the max weight the helicopter can handle with everything inside. The external maximum gross weight applies when you're carrying loads suspended outside the helicopter. And that external weight limit can actually change depending on where the load is attached.
Yeah, that makes sense when you think about it.
Right.
Like a sling load hanging right under the helicopter's center of gravity would probably be more stable than something hanging way off to the side.
Exactly. Because when the attachment point is directly beneath the helicopter's center of gravity, the load is more evenly distributed across the structure, which means less stress compared to a load that's off to the side, creating a moment.
Right. The excerpt even mentions some huge cargo helicopters that can lift insane amounts of weight as long as that load is positioned right under the CG.
Exactly.
Pretty cool. So we have these defined weight limits, which a chapter called Weight Limitations, which, yeah, makes sense. Why are these limits so important for pilots to be aware of?
These limits are there for a few key reasons, and they all boil down to safety. First, they guarantee the helicopter won't break apart in flight. They also let pilots figure out how the helicopter will perform in different situations, like during takeoff or landing. And probably most importantly, they make sure that the pilot can actually control the helicopter throughout its entire flight envelope. Now, manufacturers do build in a little wiggle room, but pilots should never intentionally go over these limits. Those safety margins are there just in case something unexpected happens, not for routinely overloading the aircraft.
Right, right. So it's not just about pushing the limits all the time. It's about having a safety net. Now, this part was a bit counterintuitive to me, and it might be for some listeners too. Operating below a minimum weight can actually also be a problem. How does that work?
You're right, it can be a little strange to think about. Basically, if the helicopter is too light, it can actually make it harder to handle. For example, you might have to use way more input on the cyclic stick, that's the main control stick in a helicopter, just to hold a steady hover. Sometimes pilots will add ballast to the helicopter, which is basically extra weight, to make it handle better. This shifts the natural position of the cyclic, giving the pilot more control. So it's not just about avoiding being too heavy. There's actually a sweet spot in the middle where the helicopter performs best.
So it's all about having enough inertia and the right balance of forces within the system.
Precisely.
Interesting. And it's not just hover control either, right?
No, not at all.
Being too light can mess with auto rotations too.
Exactly.
For listeners who might not know, that's when the engine fails and the helicopter has to glide down to the ground.
Exactly. You might end up with a longer descent time during an auto rotation. And it might be harder to get the rotor spinning at the right speed, which is obviously crucial when the engine's not working. Adding a little weight can actually make the auto rotation smoother and more predictable.
Wow. So sometimes you actually need to add weight to make the helicopter safer to fly.
You got it.
That's really interesting. On the other hand, the dangers of being overweight seem a lot more obvious, like the helicopter could just break apart in the air.
Absolutely. If you exceed the maximum weight, you risk damaging the airframe, especially if you encounter turbulence or strong gusts of wind. And it's not just about a sudden catastrophic failure either. Being overweight puts a lot of stress on all the parts of the helicopter, which can cause them to wear out much faster and potentially fail earlier than they should.
So it's not just the immediate danger of something breaking, but also the long-term impact on the helicopter's lifespan.
Exactly.
And it's not just the structure we need to think about. Being overweight can also affect how well the helicopter flies.
Absolutely. Even if you don't damage anything by being overweight, you might not have enough power to take off safely, especially in hot weather or at high altitudes. There are times when you might have to reduce the weight, even if you're technically under the maximum limit, just to make sure you can take off, climb, hover, and land safely.
Okay, so weight is clearly a huge deal. But the chapter title was Weight and Balance. So let's talk about that other critical factor, balance. More specifically, where the weight is located in the helicopter, which is known as the center of gravity, or CG.
Right. Knowing the total weight is just half the battle.
Yeah.
You also need to know how that weight is spread out throughout the helicopter. That's where the CG comes in. The Rotorcraft Flight Manual, RFM, for every helicopter tells you where the CG can be, and it's really important to load the helicopter so that the CG stays within those limits. If you don't, You could run into some serious control problems.
So if the weight isn't in the right place, the pilot might not be able to control the helicopter properly, especially in a tricky situation.
Exactly. When the helicopter is properly balanced, the pilot should be able to hold a steady hover with almost no input on the controls. They'll only need to make small adjustments for things like wind.
Right. The document uses a good analogy here to explain how the CG affects the helicopter's attitude, comparing the fuselage to a pendulum hanging from the rotor mast. Can you expand on that a little?
Sure. Imagine the main rotor mast is like the point where a pendulum hangs from. If the center of gravity of the helicopter is directly below the mast, the fuselage will hang level. But if the CG moves forward, like if there's too much weight in the front, the nose of the helicopter will naturally want to tip down. If the CG is too far back, the nose will want to tip up.
That makes sense visually. So what are the signs that the CG is too far forward, and what are the dangers of that?
A forward CG happens when there's too much weight in the front of the helicopter. It could be heavy passengers or a lot of cargo loaded up front. And it's something to really pay attention to if the helicopter's fuel tanks are located behind the rotor mast, because as you use fuel during the flight, the CG is going to move further and further forward. The first thing you'll probably notice is that the nose is tilted down when you try to hover. You'll also find yourself having to pull back on the cyclic a lot more than usual just to keep the helicopter level. This is a big warning sign because if you keep flying like that, you might run out of control authority as you burn more fuel and that CG moves even further forward. You might also have trouble slowing down and stopping the helicopter smoothly. And if the engine were to fail, you might not be able to flare the helicopter properly for a safe landing during an auto rotation.
Right. And the source material mentioned that it can be harder to tell if the CG is too far forward when you're hovering into a strong wind. Why is that?
Well, because when you're facing into a strong wind, the wind pushing against the helicopter can actually help keep the nose up, so you won't need to pull back on the cyclic as much. That's why it's super important to be aware of the wind and how it's affecting the helicopter's attitude. You don't want to mistake a forward CG for just the effects of the wind.
Gotcha. Okay, so a forward CG is definitely something to avoid. What about when the CG is too far back? What are the signs and dangers of that?
An aft CG can happen if you've got a light pilot flying solo with full fuel tanks, or if there's a lot of weight in the back of the helicopter, or a combination of those things. You'll probably notice that the tail is tilted down when you try to hover, and you'll have to push forward on the cyclic a lot, especially if you're facing into the wind. If you keep flying with an aft CG, you might not even be able to reach the helicopter's top speed because you won't have enough forward cyclic authority to lower the nose. And in really bad turbulence or strong gusts, an extreme aft CG could actually cause the helicopter to speed up beyond what you can control with the cyclic. This can lead to the rotor disc tilting dangerously backward, and if that happens, you might not be able to recover control of the helicopter. In the worst-case scenario, the rotor blades could hit the tail boom, which is obviously a very bad situation.
That's scary stuff. So it's not just about the fore and aft distribution of the weight. What about side-to-side balance? How important is that to consider?
For most smaller helicopters, especially those used for training or carrying passengers, the side-to-side balance, or lateral CG, is generally less critical than the fore and aft balance. That's mostly because these helicopters have pretty narrow cabins, and most of the equipment is installed along the center line. But there are a few exceptions to keep in mind. Some helicopters have specific requirements for which seat the pilot has to sit in if they're flying solo. And if you have a really heavy pilot on one side and full fuel tanks on the other side, that could affect the lateral CG enough to matter.
What about when you're carrying external loads? It seems like having something heavy hanging off to one side would really mess with the lateral balance.
Yeah, absolutely. When you're operating with external loads, like during construction work or search and rescue operations, where you might have a hoist hanging off to one side, you'll almost certainly have to use a lot of lateral cyclic input just to keep the helicopter flying straight. And if you're using that much lateral cyclic, it can make it a lot harder to control the helicopter in the fore and aft direction as well.
Yeah.
To deal with potential lateral imbalances, manufacturers often try to design things like hoists and fuel tanks so that they help offset the forces they create.
Right. So it's all about anticipating and mitigating those imbalances. So how do pilots actually figure all of this stuff out? How do they calculate the weight and balance before a flight?
It boils down to two main questions that every pilot has to answer before taking off. First, is the total weight of the helicopter less than or equal to the maximum allowable weight? And second is the center of gravity located within the safe limit specified in the RFM, not just before takeoff, but also throughout the entire flight, considering things like how much fuel they'll burn.
So for the first question about the total weight, it's basically just adding up the weight of the empty helicopter plus everything you're putting into it, like the crew, passengers, fuel, cargo, everything, right?
Exactly. You start with the documented empty weight of the helicopter, then you add the weight of everyone and everything that's going on board. Then you just add all those weights up and make sure the total doesn't go over the maximum allowable weight for that particular helicopter.
Okay, that makes sense. But figuring out the center of gravity seems like it would be a little more complicated than just adding weights together. The source mentioned using some special information from the RFM. How does that work?
Yeah, the RFM is your go-to guide for figuring out the CG. It'll have charts, tables, or graphs that tell you how to calculate the CG based on where everything is loaded. But it's important to remember that these calculations are only as good as the information you put in. So you need to get the most accurate weights possible for everything that's going on board. That might mean politely asking your passengers for their weight, actually weighing any cargo, and using the standard weights for things like fuel and oil if you don't know their exact weight.
Right, and the source actually provided some of those standard weights for common aviation fluids, which is helpful.
Exactly. Figure 6.2 in the source material lists the standard weights for things like aviation gasoline and jet fuel. It also has an important reminder to convert oil quantities from quarts to gallons before you use those weights, because weight is typically given in pounds per gallon. It's a simple conversion, but it's easy to overlook.
Gotcha. Okay, so you've got all the weights of everything on board. How do you actually figure out where that weight is located relative to the helicopter? That's where this concept of a reference datum comes in, right?
Precisely. To determine the balance, or CG, you need to know where the weight is located in relation to a fixed point on the helicopter called the reference datum. The horizontal reference datum is like an imaginary line or point that the manufacturer defines along the length of the helicopter. All the distances used in the weight and balance calculations are measured from this datum. Now, here's the thing. There's no rule about where this datum has to be. It could be at the rotor mast, the nose of the helicopter, or even somewhere in front of the helicopter.
So the location of this datum is a bit arbitrary. Does it make the calculations harder depending on where it is?
It can affect whether you end up with positive or negative numbers in your calculations. Like figure 6.3 in the source material shows how some manufacturers put the datum line in front of the helicopter. This means all the distances you calculate will be positive, which can make things a bit simpler. But other manufacturers might put the datum somewhere in the middle of the helicopter, which could mean you end up with both positive and negative distances, depending on where the weight is located. The key thing is to remember that the manufacturer defines the datum in the RFM, and that's the reference point you have to use for your calculations.
Gotcha. And then there's a lateral reference datum too, right? Where's that located?
Right. The lateral datum is usually located right down the center line of the helicopter. Distances to the left or right of this center line will be positive or negative, respectively. But as we discussed earlier, lateral balance is usually less critical for smaller helicopters because they're pretty narrow and most of the equipment is installed near the center line.
All right, so this has been a pretty thorough look at helicopter weight and balance. The key takeaways here are that you need to stay within the weight limits and make sure the center of gravity is in the right spot. This isn't just about the helicopter staying in one piece, it's about making sure it flies safely and predictably. And as we've seen, even small changes in the weight distribution can make a huge difference.
Exactly. It's both about the total weight and where that weight is located. Understanding these fundamentals can really help you appreciate the complexity of flying helicopters safely.
Yeah, and hopefully this has shown you that those pre-flight weight and balance checks aren't just some tedious paperwork exercise. They're absolutely essential for safety. So here's a thought for you to ponder. If something as seemingly simple as shifting a few pounds around can completely change how a helicopter flies, what other seemingly small factors in other complex systems, maybe even outside of aviation, might have similarly big and unexpected consequences? It really makes you think about the interconnectedness of things, doesn't it? And for those of you who want to learn even more about weight and balance calculations, definitely check out the Aircraft Weight and Balance Handbook, FAH 80831. It's a great resource with tons of details and practical examples.
Absolutely.
Thanks for listening to The Deep Dive.
Until next time.